Hey, good morning, guys, and namaste. All right, today what we're going to do is we're going to go through section 25.5 on the solar system, and this would be the last section that we do in terms of astronomy. So here we go. All right. Okay, so here are the slides, and just to go through them. Okay, so okay, so it all starts with one of these. All stars and planets start with nebula, and that's in part of the notes that we talked about before. And a nebula is a cloud in space of mainly hydrogen gas, but it's not just hydrogen gas. Every other element is in there in small amounts. It's mainly hydrogen, but there's pieces of gold in there. There's pieces of cobalt in there. There's water in there. There's H2O in there, and carbon dioxide and things like that are all in there in small amounts. And what nebula do, where they come from, is they come from other stars that have exploded, supernovas, all right? And their outer layers go out in the space and they form these nebula, and nebula eventually form new stars. And here's a picture of a nebula right now. And inside the nebula, certain parts of it are said to collapse and due to gravity. And when they do, they start to form stars. Okay, and let's talk about how that happens. Okay, so what winds up happening is nebula are when we talked about gravity, everything attracts everything else. So each little molecule inside the nebula attracts every other molecule or atom inside the nebula. And it might take hundreds of thousands or even millions of years, but eventually and slowly nebula start to shrink due to its own internal gravity. And so when that happens, we say that it collapses. So you start out with nebula and it gets smaller and smaller and smaller. And as it shrinks, it usually starts to rotate, okay? Almost like when you see water going down the drain in your tub when you let the water out, okay? And then when it rotates, when things rotate, they tend to flatten out when they do that, okay? And then you get, over time, the nebula shrinks and starts to rotate, and you get what's called a protoplanetary disk. The center part gets really hot because when the gravity inside there makes the molecules closer together, or the atoms of hydrogen, I say, closer together. And when you compress a gas, it gets hot. And anyone who knows anything about diesel engines knows that that's what a diesel engine is based upon. When you compress the fuel-air mixture inside the cylinder, it gets hot and self-ignites and so on. And it's the same sort of thing here, except it happens on steroids. When the compressed hydrogen at the center, due to gravity, eventually reaches 15 million degrees. And when that happens, it starts to light up and undergo fusion, and you get a little protostar in the center, okay? Now, once this happens, anything that is light or doesn't survive high temperatures, like ice or something like that, okay, is melted or vaporized away and gets pushed farther out in the clouds. Anything that's harder or denser, like rock or metal or things like that, can hang around there, all right? And that's kind of important. Okay. All right. So the center gets hotter, fusion begins. All right. Harder substances from the center come together through gravity, and you start to get what's called a planetesimal. All right. Okay, the process, I'll let you guys copy this down on your own time. All right. But just to save a little time on this video. Okay. So, there are harder parts in the cloud, all right? Like I said, there's bits of metal in there, bits of rock and things like that. And these obviously have more gravity because they're bigger. And they come together due to gravity. And there's a word for that. And I want you to memorize that word and write it down. The word is called accrete. We say the process is called accretion. So that's the process of things coming together due to gravity and then growing bigger, because as it gets bigger, it has even more gravity. So it attracts even more stuff to it. And you start to grow and form something called a planetesimal, which here's a picture of them right there. So these, like asteroid type things, these would be not planets yet, but we would say at this stage they're called planetesimals. Now, because they're getting bigger, they do two things. They crash into each other, all right, but they also have a little bit of gravity, so things, other planetismals are attracted to them, and so they start to grow or accrete, and eventually they turn into planets, or at least a protoplanet. Here's what the Earth would have looked like when it was first forming. Because remember, when these things are crashing into each other, they generate heat. And so initially the Earth was all molten, and it would have just been like this big molten ball of iron and rock and stuff floating in space. And because it was getting bigger, it was getting more gravity, and would have attracted smaller objects that were part of the initial nebula to it, and then got even bigger, and they would have crashed and all that, and it would have been very, very violent, okay, for a billion years or so, until eventually there's no more of these guys to suck into it, and then the planet starts to stabilize and it doesn't grow or get any bigger anymore. So planetismals grow and they form what are called protoplanets. All right. Okay. The inner planets are smaller and denser because lighter substances like ice or things that require coldness to form could not survive near the sun. All right. So the inner planets are in our solar system, Mercury, Venus, Earth, and Mars, are made of dense materials like rock and metal. Okay, make sure you know the inner planets. After Mars, there's this huge space before you get to the next planet, which is Jupiter, and Jupiter forms the beginning of what are called the outer solar system, or the outer planets. These planets are actually you can't stand on them. They don't have a surface. They're made for the most part of gas, hydrogen gas for the most part. Okay, and they also have methane ice in there and water ice in them and things like that, but they're gaseous. They're called gas giants or Jovians. Okay, and they are said to be low density. Now they're bigger than the Earth, but their density is less. What does that mean? That means if you took Saturn and you put Saturn on an ocean big enough to hold it, which there is none, but if you get, it would actually float. The Earth would not. Neither would Mars, neither would Mercury or Venus, but Jupiter, Saturn, Uranus, and Neptune would. They're low density. They're bigger, they have more gravity because they're bigger, but they're lower density. And here are the outer planets. These are gas giants. They're much bigger than Earth, okay? But they're mainly made out of hydrogen gas for the most part. Okay. And then after the planets properly formed, what was left over were planets that didn't quite make it. And we call these dwarf planets. Pluto is the one that you guys all know of the best, all right? Pluto did not, it's not quite a planet. We used to consider it a planet, and then we came up a few years ago with this category of dwarf planets. We took Pluto out of the planets and made it a dwarf planet, whatever. But these things are farther out beyond the orbit of Neptune, and they're smaller things, smaller planets maybe. Pluto, by the way, is not even the size of the United States. So that's how small that is, okay? Remember that George Romero's second zombie movie is Dawn of the Dead, 1978. Yes, Jake Richard, you must write this down. Dawn of the Dead. I already know how to survive a zombie apocalypse, so I'm not doing this for myself. Tyler Burdick. So remember that. Okay, so there you have that. Okay, and that's 25.5. And at this point, I can exit. And good luck. And Golis out.